All right, Math 149, Sample Exam 3. Okay, Math 149, Sample Exam, actually 1, messed up already. All right, in this exam, we're going to go over limits and some derivatives. But before we start going over limits and derivatives, let's just review some of the algebra that you're going to need. The first thing is the different rules of exponent. X to the negative 1 is 1 over x to the n. The division rule, x over a over b, is x a minus b. And then also you're going to need the root. If you have nth root of x, that's x to the 1/2. Also, you're going to need the power rule of exponent as well when we add the exponent. And then later on, we're going to talk about the different things that you need for derivative. We're going to start with problem number 1. Problem number 1, we're looking for the limit as approaching a point. Now remember, the limit doesn't mean the value of the function. For example, if you look at our problem number 1 here, where I have limit of x squared minus 2x minus 15 over x squared minus 4x minus 12 as x approaches negative 3. Now, if you just go ahead and replace negative 3 into the limit, what's going to happen? You're going to get like 0 over 0. Well, that's not really what we're looking for. That's the value of the function. We know it's undefined at that point. But there are two ways you can find the limit. One way is using the algebra. Basically, what you're going to do is you're going to factor your numerator and denominator. X minus 5, x plus 3, and the denominator is x minus, actually this number here was 21, minus 7, x plus 3. Now, see, what caused the 0 over 0 was x plus 3 and over x plus 3, which in this case, we could reduce them out. And you're going to end up with the limit x approaching negative 3, x minus 5, x minus 7. Now you can go ahead and plug negative 3 where you have x. This gives you negative 8 over negative 10, which reduces that to 4/5. Now, the second technique here is using the table. Now, if you're using the table, basically, you put in your y equal to this function, your original function, make sure you put them in parentheses. And then, basically, we're going to do it at like negative 3.001. We know right at negative 3, you're going to get error on your calculator because it's undefined, and negative 2.99. In both cases, the left and right limit gives you the y value of 0.8. Now, looking at this problem, you're going to see that the limit doesn't mean the actual value. It means approaching. Like when you're coming, like if you're looking at the graph, it's coming from the left or right-hand side of